Hello, welcome. I'm James Shore. I am the host of a screencast called Let's Code Test-Driven JavaScript, which you can find at letscodejavascript.com. And I'm co-author of a book called The Art of Agile Development, which is out at the O'Reilly booth if you're interested. We've got a lot of ground to cover, so let's go ahead and just get right into it. One of the unique features of Agile, and some people would say the defining feature of Agile, is the ability for people with a business perspective to change their mind, for you to be able to change direction at any moment. This isn't free. If you just go ahead and change your mind at any time, you're going to end up with a giant pile of technical debt. So what we have in Agile is this rich web of supporting practices that allow you to change your mind and change direction at any given time. Two of the most fundamental are incremental design and simple design. Simple design says we build the smallest thing that we can for what we need to do right now, and incremental design says we change it over time as our needs change. These are both supported by refactoring. Refactoring is how we are able to change our design over time. And though that is supported by collective code ownership, so anybody on the team can change the code, and test-driven development. We have tests that support us when we make changes to our code. These three things take a lot of self-discipline. And so pair programming, although a lot of people don't do it anymore, is a really useful tool for helping create that self-discipline. If you don't do pair programming, you've got to find some other way to get that self-discipline into the team. Collective code ownership depends on continuous integration. If we're going to have everybody make changes to the code, we all need to be working from the same version. And those are both, test-driven development and continuous integration, are both supported by fast builds. Test-driven development gets extremely painful once your build takes longer than about 10 seconds, or at least the part that you care about. And honestly, if it's more than 5 seconds, I'm not happy. So this is the web of practices that are required. One view of the web of practices that are required to do what Agile is about, which is change direction at any time. And if you're not doing these things, again, technical debt is in your future, or probably here already. So we know how to do these things. We don't all do them, but we know how to do these things on the back end. We know how to do it in Java and C# and Python and Ruby on Rails and even Node.js. The question I have for you is, how do we do this on the front end? How do we do this in the browser? Because if we don't do these things, we can't make changes. How many of you have the experience of having the ability to make lots of changes to your back end, but whenever you make the changes to your front end CSS or JavaScript, you feel like you're walking into a minefield? Wow, nearly everybody in the room raised their hand. That's certainly been my experience in the past as well. So this talk is about that. Many of these practices are completely independent of language. You can do pair programming working in any language whatsoever. So this talk is about these four practices: automated builds, continuous integration, test-driven development, and refactoring. Or at least it was 2 hours ago. I timed it, and we cannot cover all four of these in 40 minutes. So fast automated builds and continuous integration are going to get skipped past. We're going to focus on test-driven development and refactoring, because I think there's a lot more fascinating stuff there. So automated builds. This is what I think is important for automated builds. These are the popular tools. Most of them suck. All right, Jake is the one I like. Now that I've been, okay, blah, blah, blah. So yes, I like Jake. Build. All right. So here is an example of Jake running the build. You're welcome to use whatever tools you like, but according to my criteria, which I just zoomed past, this is the best one that I'm aware of. It gives you the ability to create tasks, have them depend on other tasks, and give descriptions of those tasks so that you can type at the command line, show me what I can do, and get a nice list. And I've got it set up with Karma, an automated cross-browser testing tool, so that when I run my tests, they run on Firefox, but also Chrome and Safari, and IE10 is one of the browsers I've set up right now. Karma will allow you to test any browser, physical or desktop, that's connected to your network. So you can I could take out my phone and connect to Karma server on my computer if I was on a compatible network. Not right now, don't try it. I can also connect to the iOS simulator and even the Android emulator, which is what I've set up here. And when I run my tests in the automated build, it will run our tests on all of these browsers. The build will lint everything, it will test the code, and it will give me a single unambiguous success or failure message at the end in about 3 seconds. All right, so that's the automated build. Next, continuous integration. Or not. Okay, test-driven development and refactoring. If we have time at the end, I'll be happy to get into it. Now, this is an expert-level session. We're going to move pretty fast. I don't have a lot of time, and I want to cover a lot of ground. So I may not have a lot of time for questions, but I will be available afterwards. I'm very happy to take questions and just talk in the lobby. I am assuming some basic knowledge of JavaScript, CSS, and some familiarity with Agile engineering practices. I'm assuming you know these things, but maybe not how to put them all together. And for those of you who really know this stuff well, I guarantee there's going to be some new information in this talk, because we're going to cover test-driven development and refactoring of 2 of the major front-end languages, JavaScript and CSS. The other one being HTML, of course. Okay. So the example app that I've got here is just the standard media object that was created by Nicole Sullivan of object-oriented CSS fame. She had this insight that many web pages have a common repeated pattern, which is an image to the left of some text. She called it the media object. Now, for the sake of example today, what we're going to do is we're going to test drive the media object and some toggle behavior. Very simple little behavior, but I think this behavior will illustrate what's needed in order to do front-end, test-driven development of front-end code. So when we click the icon, the body text either appears or disappears. And for those of you in the audience who are JavaScript programmers, you know how to do this in your sleep. That's not the question. The question is, do you know how to test drive this? Do you know how to refactor code that does this? So that's what we're going to build. We've got 35 minutes. Let's get to it. Let me go ahead and reset this. So what we're going to build is a little library to implement that toggle behavior. So what we want is when this icon is clicked for the body to appear and disappear. And so we're going to implement a library, very simple library, that takes 2 elements and a CSS class. When one of the elements is clicked, the CSS class will be applied to the other element and toggled on and off as the clicking happens. That will allow us to do this right here. First thing I want to do is just make sure, now test-driven development, the test-driven development cycle, you've probably heard of it as red-green refactor. I always start out with a first step before red-green refactor, which is think. What is something small that we can build in a few lines of code? What's our next step, basically? So what would, this is a rhetorical question, what would something small be that we could do first? And for me, because I have trouble thinking through big problems like building all the toggle logic, I start with a very simple question of how are we going to run this? How is this code going to start? And then that takes us into the red part of the red-green refactor cycle. Write a test that fails. That part of the cycle is a design step. It's an opportunity to think about the design of our code. So we're going to have this just run. And at this point, we need to figure out what we're going to call. I'm going to call it a init. That's all. Just that just that much. I'm not going to add anything else to this. This test should fail. And in fact, it does. There is no init right here. One disadvantage of Karma is it has really lousy output, so you might find yourself searching for your error messages. Every browser is going to output its own thing, but it's generally repeated. Okay. So in order to implement this, make this pass. So we've got, think about a small step, write a test to make it fail. That's a design activity. Write a little bit of code to make it pass. That should usually be pretty easy. And in this case, we'll write our init function. Just like that. And there we go. Okay. Refactor, there's really nothing to refactor here. So we go back around again. Think, what's something small we could do next? Well, jumping straight to toggling, that's a big step. So I want to take a smaller step than that. What I'm thinking is if we have this toggle method, this toggle library, simply add the class. That will get us a step closer to being able to toggle. And because this existing test doesn't add a lot of value, I'm just going to replace it with a new test. So let's say that the toggle adds a CSS class to an element. So we're going to call toggle.init. Now remember, classic test definition is arrange, act, assert. And on the front end, because we're often manipulating the DOM, we also need a fourth step, which is reset. We need to erase the stuff that we create. So we're going to pass in some sort of element and some sort of CSS class to our toggle init, and then we're going to expect that we're going to check to see if that CSS class is present. And we're going to need to set this up with the element that's going to be modified. And then at the end, we'll want to erase the element. These four steps right here, these things, this is fundamental. This is what you're going to do when you're doing JavaScript testing on the front end. And the way you do it is just through standard DOM manipulation. So to create the element, or you can use a library like jQuery, but I'm just going to use the DOM. So we'll create the element by saying document.createElement. And we will add it to the body. Now, technically, you don't always need to append your elements to the document, but there are some browsers that start acting very strange when you do DOM queries on elements that are not in the document. So I just always put them in. And then we'll need to assert on it. To check that the CSS class is present, since we are only going back to IE10, we can use the class list property. So I'm going to assert that it's true that the element's class list contains our CSS class. And I'm going to go ahead and put in a little documentation on that. And if I did that right, that should fail, saying should contain class, expected false to be true. So there we go, failing test. Now let's go ahead and make it pass. We'll need to take in our element and our class name. And this is pretty easy to implement. We will just add it to our elements class list. And there we go. So now we get to go around again. Oh, wait, I forgot about reset, didn't I? Let's go ahead and take the element back out. That can be done by just saying element.remove. That is a DOM, one of the DOM functions. Unfortunately, and this is why we do cross-browser testing, it does not work on IE10. So we're going to have to go back and use the old-fashioned, clunkier version, which looks like this. So you can see here the previous test run passed on everything, except for IE10. It says object doesn't support property or method, remove. But by changing it to element.parentNode.removeChild, now it works. All right, let's go ahead and refactor. This reset is something that you're going to do a lot, and it won't run if you get an exception, which can cause future tests to behave strangely. So I like to pull out the reset into the before each and after each functions. I'm using Mocha here for my testing, which means that I can implement a before each and an after each function that will run before and after every test. And what I'm going to do is I'm going to set up a container that all of my test elements will go inside, so that in my after each I can remove that container and have everything get cleaned up automatically for me. So if we add it there and remove it here, oops, can't do that. And then we have our element be put into the container here. We should no longer need to remove it down here. Now, live coding, I have no idea if this is going to work. Okay, good. So there's a little refactoring. Let's go back around the loop again. So we've got this adding a CSS class to our element, but of course that's not how we want this to work. We want it to add the CSS class when a different element is clicked. So, and that's starting to get closer to what we really want to do here, isn't it? So let's go ahead and put that in. To do that, we're going to need an element that can be clicked. And I noticed that we've got this sort of clunky two-line piece of code here to add elements. So let's go ahead and factor that out into its own function. We'll call that add div. So there's our add div function. I'm using WebStorm here, which has automated refactorings, if any of you were wondering how I did that. So now I can take this element and this, let's rename it. We'll call it target. This is the target element that we're going to change. And we've got a new div that we're going to click. We'll want to pass that through here. And actually, before we pass that through, we no longer want our target element to have the class applied right away, right? We don't want it to be applied until the click happens. So let's go ahead and change this from being assert is true to assert is false. It should not contain the class before the click. That should fail. And in fact, it does. It's saying expected true to be false, so that's the error we expected. And we can fix it just by not applying the class, and that will solve it. All right, now let's go ahead and implement the Cliq behavior. So before we click, we should not contain the class, and then we can do the click, and now we should expect the class will be present on our target element. So it should contain the class after we click. You could do this with multiple tests, by the way, but I feel like this, in this particular case, doing multiple asserts in a row reads more clearly. That's very much a matter of taste, and if you were to implement this, you might choose to do it differently. Or if we were pairing, you might say, I don't like this, and we could refactor the test. Anyway, this should fail because we don't have any Cliq behavior. And yes, it does not contain the class after the click. So we'll need to pass the ClickMe element through. We'll take it here. And then we can add an event listener on the click event to add that class when the click occurs. And hopefully I did that right. And yes, I did. So there we go. It's time to refactor, red-green refactor. Don't ever forget the refactor part. As I look at this, I notice a lot of duplication here. So I'm going to go ahead and factor out this common class name into a variable. And let's call that CSS class, like that, and some class name. And that should still work because it was a pretty mechanical refactoring. And this right here, this target.classlist.contains, we're doing that all over the place. I'm going to factor that out into a method called, what did I say I want to call it? Let's call it hasClass. And we'll do the same thing here. And that should still work. And in fact, it does. All right. Let's implement the toggle behavior. So rather than adding the class to the element, we want it to toggle the CSS class on an element when another element is clicked. By the way, you'll notice that I'm changing the existing test a lot in this particular example. It's because the code is so simple. If we had more sophisticated behavior, I'd probably have multiple tests. But in this case, it just seems like leaving the other tests around wouldn't add a lot of value. They'd actually make the code harder to understand rather than more easy to understand. And my tests are a form of documentation. So I think very carefully about this as I'm writing my test. What's going to be the easiest to understand? And am I losing any coverage by not keeping these old tests? But in this case, I don't think I've lost anything. So I'm going to go ahead and have this do another click, and we'll say that it's false and should not contain class after another click. Of course, I could keep on doing this forever, but I'm pretty confident if this works, then it will keep on working. This should fail because we don't have that toggle behavior implemented. It does should not contain class after another click was the wrong answer. That's super easy to fix, though, because we can just say toggle on the class list property. And there we go. Now, when we run our application, I've already got it hooked up in the actual web page. When we run the application, we will see there's our behavior. What we don't have yet is any CSS. So that's what I want to get into next. Just like we can do test-driven development of our JavaScript, we can also do test-driven development of our CSS. It's not easy, and I spent a lot of many months creating a tool to make this possible. The tool is called Quixote, and I'll have the link for you at the end of the talk. All right, so let's go ahead and set this aside and open up our CSS test. So here's our CSS. It's just got the ability to make things visible and invisible. That's the class that we are toggling in the actual live or the actual local host code. And here is a test file that I've got set up with nothing in it except for the Quixote library. First thing we're going to need to do is set up Quixote. The way we do that is we call the before function once before all of our tests. The reason we only do this once is because Quixote works by creating a test frame where it puts all your elements into that frame. And creating that test frame is a little bit expensive. It's 50 milliseconds or something like that. I want my test to run in about a millisecond or less. So 50 milliseconds is too expensive to do before every test. So we're going to ask Quixote to create a frame for us. The way you do that is you say quixote.createFrame, pass in some options. In this case, the options we care about is our style sheet. I've got Karma configured to serve our style sheet, which is right here, source/screen.css. I've got it configured to serve it out of the base directory. That is an asynchronous operation, so I pass in done to it. So Mocha will wait until Quixote is finished creating the frame. After all of our tests are done, we will remove the frame to clean up after ourselves. And then before every test, we'll reset the frame so that any changes we made in any particular test go away. And then we will set up the HTML that we are actually going to test. In this case, it's the media object HTML. So this is needed for our test, but it's also a form of documentation for people reading this unit test. This is an actual unit test of CSS. You can use Quixote to do integration tests as well and actually load a web page anywhere off the web. But I don't think anybody's really done CSS unit testing before now, and that test-driven development cycle that I was showing you earlier works best when you do a unit testing style. It lets you get a real detail-oriented look at your work, and you're going to see that in a moment. So to create our media object, let's go ahead and pull it here. It's going to also have a figure and a body. To create that media object, we'll add the HTML, and it looks like this. We've got a div with the class of media. And that div is going to contain another div, or actually usually it's an image, but a div will work for us, which I'm going to give an ID just so we can access it more easily. And the class, I'm going to use the BEM notation, block element modifier, so I'm going to call it media figure. And because this isn't an actual image, I'm going to give it a width and a height so that the CSS works properly. And we'll put some text in there in case we need to do any manual debugging. Hopefully that won't happen because we don't have a lot of time. And do the same for the body. Call that media body. And there we go. We'll give it a name so our test can give us nice error messages. And that is the media object. So this will create this chunk of HTML and add it to the test frame. After that, I want to pull out our figure so we can make assertions about them. So I'll say figure, get that out of the frame. You can use any selector you like here. That's why I put the ID in. And similarly for the body. And if I transcribed my notes correctly, this will work. Hey, there we go. Okay, so we've got this media object. It's not implemented at all yet. The first thing, so now we get to start doing that detail-oriented, test-driven development cycle. What is one small thing that we want our media object to do? And maybe we start with something trivial, just like we started with something trivial in our JavaScript, the init function call. In this case, what I'm going to say is that the figure is supposed to be flush left to its container. We want it to be right on the left-hand side of whatever it's embedded in. So we can implement that by saying the media object positions the figure flush to the left of its container. And the way we do that in Quixote is we take the element that we want to make assertions about, in this case the figure, and we call the assert method and pass in a bunch of selectors. Now that list of selectors will grow over time as I get pull requests, hint, hint. But right now what we have support for is all the layout stuff, which is actually one of the most interesting, I think. You can also make assertions about any CSS property, but not necessarily in the fancy way I'm going to show you here. So we want the left side of the figure to be flush to the left of the container, which in this case is the frame's body. We want that left edge to be the same as the other left edge. And one of the neat things about Quixote, if I say so myself, is that you can write all your tests completely relative. You don't have to write hard-coded numbers. Now the reality is that the left side of the frame, or the left side of the body is 8 pixels from the left side of the frame because I haven't set up any body margins, and that's just the default. So what this is saying is that the left should be 8, but I don't have that hard-coded, and I think this is a lot more readable. So that should happen by default. Let's go ahead and run that and see that it is true. It is. Great. Let's do something a little more complicated. We want this part to be aligned at the top, same height as the figure. It should all be up together. So let's go ahead and implement that. It aligns the top edge of the figure and body. So we can say that we can make an assertion on the body, or we could do it on the figure, it doesn't really matter, and say the top edge is the same as the figure's top edge. And if we run that, we should get a failure saying, yeah, the top edge of the body was 100 pixels lower than expected. That's the height of the figure, if you recall. We expected to be right at the top at 8 pixels, top edge of the figure, but it was at 108. So no surprise there, the way we implement that. Is by floating that figure left. And that should pass. And it does. See how we get that really nice detail-oriented cycle going here in our CSS, implementing our CSS just like we did with our JavaScript. So if we look at this now, we can see that, yes, it is right up to the top. It's not quite done yet, though. We're floating, and so we are missing a nice gap here, and also the media object should be aligned on the left. Now we can test this by saying that the body should be to the right of the figure, because right now the way floats work is the display is the boundary of this body text is actually the same as the figure. So if we write our test that says it positions body to the right of the figure, that will give us an opportunity to fix this. Let's say that the body left edge is the same as the figure's right edge plus 10 pixels. And you can also say things like it's the left edge, it's the right edge plus the width of another element, or half the width of another element, or whatever relative sizing you want to use. So this should fail. And it does. It's 110 pixels further left than expected. Expected it to be to the right of that figure, but it was right up against the left edge. So implementing this, well, there's a trick. We can make the body have a new display context by setting overflow to hidden. And if we do that, then our test should pass. But it didn't. Oh, I forgot the 10 pixels. See right there, it says 10 pixels further left than expected. And that wasn't intentional, but I make that mistake every single time. Part of the reason I do test-driven development is because I'm very error-prone. I do test-driven development not because I can write perfect code, but because I can't write perfect code. All right, that should work now. Very good. So what do we have left to do? Well, it's a little hard to show, but because we're using a float, if we put another element underneath the media object, it will be floated to the right of the figure as well. We don't want that. We want it to be below the media object. So let's go ahead and implement that as well. So it's going to position subsequent elements below the media object. Now to do this, we're going to have to create a subsequent element, and that's, remember, we're resetting the frame every time, so it's okay to create new elements. The way we do that is we just say frame.add, and we will put in a subsequent element. And let's call it subsequent so our error messages are more readable. Then we can make an assertion about that element. We can say that we expect the left edge of the element to be on the left edge of the frame, so frame.body left, and that the top of the element is below the figure. So we can say the top of the element is exactly aligned with the bottom of the figure. And if I did that right, we should get a failure. Yeah, that subsequent element is 81 pixels higher than expected because it's being floated. So to fix that, really easy, we can just do that display context trick again. And there we go, our tests are passing. Let's take a look at it. So there we go. Now there's a little problem here. Our paragraphs have margins, and using that display trick caused the margin to no longer collapse. The margin is now contained within the media object. And sometimes that's what you want, but I don't want it in this case. So let's go ahead and fix that. Let's write a new test that says it allows elements margins to extend outside the media object. And to do that, we're going to have to get the DOM element for the body, and we're going to set the style and give it a margin, say 15 pixels. And then we'll make an assertion that the top of the element is still at the same place as the top of the figure. Margins are ignored in these positioning calculations. So if we look at that, that should fail. Yes, it's 15 pixels lower than we expected. So we need to make this pass. We need to clear those floats without bringing the margins in. These kinds of nitpicky details are really common in CSS, and I love being able to do TDD to sort of flesh them out and document why we're doing some of the weird CSS rules we're doing. Speaking of which, this is a clear fix that we're going to use here. And there we go. So, test-driven development of CSS. Now, why do we do test-driven development? Well, many reasons. Documentation causes us to think deeply about design. It's the small steps I find to be really useful in preventing errors, regression testing. And in the context of Agile, one of the major reasons we do this is so that we can do adaptive planning. The reason we want to do adaptive planning is because we want to be able to change our mind. In order to do adaptive planning, we need to be able to change our design. We need to be able to refactor. In order to refactor, we need test-driven development. So we've got sort of a nasty bit of design here. None of this is all that understandable unless you've had the misfortune of being embedded in the CSS world for a while, in which case it looks perfectly normal to you. Stockholm Syndrome. But there's new tools available to us, like Flexbox. We should be able to refactor this and have all of our tests still pass. So let's do that. Let's change this media object to use Flexbox. This code, by the way, is courtesy of Philip Walton. I don't know Flexbox at all, but I copied it. So we don't need the float anymore. And we don't need this display context trick. What we can do is just say that the body takes 100% of the space after the image. Nice and clean. All we have to do is run our tests and see that it works. Except it doesn't, which is why we have the tests. The margin was included. And that, like I said, I don't know Flexbox. Maybe you can fix that, maybe you can't. But for now, let's just turn that test off. Time-honored tradition. And see what we can see. Well, what we see is that will work on Chrome and Chrome Mobile, but it doesn't work on IE10, and it doesn't work on Mobile Safari 8. So rather than spending the time trying to figure out that margin issue, I'm going to say, well, that was a nice idea, but its time hasn't come yet. I'm going to put this back the way it was. And there we go. Test-driven development of front-end code, JavaScript, and CSS, which I think are the two languages on the front end that need it the most. And I'm even on time. I can take one question, I think, in the 1.5 minutes I have left. Well, that was the part I skipped. CI servers are really poorly named. They're actually build runners. And because of the multiple browsers, it's very low return on investment to automate starting up the browsers. Now, if you can automatically start the browsers, then this code, Karma, for example, will run on a CI server or build automation server just fine. But spinning up Android and the iOS simulator and whatever physical devices you want to test and the virtual machines, it's pretty expensive, so I just do it manually. I think that having a server automatically do that for me is really cool and kind of a waste of time. So I do manual continuous integration. All right. Now that I've alienated everybody as I was planning, thank you for coming.